Today we will mainly walk through the LLaMa family, right? So in the past series, we have talked about LLaMa 1, LLaMa 2, and LLaMa 3 just released recently. But this session will focus on more of the variants of the LLaMa models like that developed on top of LLaMa, like Alpaca, Vicuna, and LLaVA. Yeah, it seems all these names is kind of related to LLaMa in some way. So this is kind of the family tree of the LLaMa, right? So it has like a Chinese branch where the LLaMa is adapted to kind of Chinese language and also adapted to different use cases like lawyer, chat medicine, and this is also a law related GPT. Another major branch is based on Alpaca. It's released by Stanford. So I think it's one interesting part is only using synthetic data from the OpenAI text model to further fine tune the LLaMa model, like especially LLaMa 1, to follow the instruction better. The third branch is the Vicuna model, and you see here is like it further fine tune the LLaMa on chat data. So the chat data is from the LLM user and the LLM conversation chat data, and use that is kind of also the output from ChatGPT style data set to fine tune the LLaMa as a kind of assistant and become more useful in the conversation style instructions. And then on top of Vicuna, people have also explored the multimodal models, right? That can understand not just text, but also images. And then that leads to LLaVA model. So this is like a language vision understanding model. And then, yeah, so based on LLaVA, there's also like a different branches here. So as you see what is the root, kind of the root node of these important branches. So that's the main focus of this talk, is to talk about like this Alpaca, Vicuna, and LLaVA can also gives you an idea about how can we adapt the LLaMa model for multi-modalities. So I want to give an overview of the LLaMa 1, 2, 3 first. So LLaMa 3 is quite new, so I added it today. And you see like the LLaMa 1 is a pre-trained model only, it's not instruction fine-tuned. And LLaMa 2 provide both the pre-trained version and instruction fine-tuned version. They call LLaMa 2 chat. And LLaMa 3 the same, they release both the pre-trained version, not instruction fine-tuned, and the instruction fine-tuned version. And also they come in different parameters from 7 billion to 30 billion, right? And also LLaMa 3, they mentioned that they are also going to release 400 billion plus models later. The context length, like every time they increase the version, they double the context length as an input. And for LLaMa 3, like previously, like LLaMa 1 is not group queried attention. It's not using this technique to speed up the inference. For LLaMa 2, only the larger model use the GQA, and for LLaMa 3, they use it all for all three, all different sizes of models. And in terms of the pre-training tokens, so basically this is the size of the training data that is used to pre-train the model. So like LLaMa 1 is about 1 trillion tokens to 1.5 trillion, and LLaMa 2 is 2 trillion, and LLaMa 3 they increase it to 15 trillion. So yeah, so I think we would expect another increase of performance from LLaMa 3. Because the LLaMa is the open source model, right? So basically all their tokens needs to come from open source datasets, or else their models cannot be open sourced. So that's the key part, that they want to show that the open source LLM that fully pre-trained on open source datasets can achieve comparable performance comparing to the closed datasets like from OpenAI. So let's first look at the Alpaca. The challenges that Alpaca is trying to address is they want to train a high quality instruction following model under academic budget. So basically just like they want to find a way for the academic to explore how can they efficiently train or instructor fine tune LM without like spending thousands or even millions of dollars, right? So they want to see, okay, can we just use LLaMa, for example, because it's already open source and they can use it any way they like for research. But they also need a high quality instruction following data. Because they cannot kind of hire lots of contractors to provide this data for them, right? So they need a way to how to connect this high quality instruction following data to fine tune a pre-trained open source language model such as LLaMa. And then they propose to use the self-instruction. Self-instruction is another published paper just focusing on self-instruct and to show that how a LLM can improve itself by providing the instruction and also instances, examples to the instructions, and then use these self-generated instructions and examples to fine-tune themselves to improve the performance. I think it's a very interesting idea. So the Alpaca framework is this. So the framework is actually very simple. It's not even a paper. They just publish on their website. They show that they just use some C tasks, they only manually human crafted 175 self-instruct task, and then they use the OpenAI text Davinci model to generate more instruction following examples. Right, so for example, this is a seed examples, like instruction and output. Then they use existing large LM to augment the data sets and to generate automatically generate more instruction and examples from existing LM. And then they use this synthetic data sets to fine tune the LLaMa model, which is like a smaller model, they choose a 7 billion, so it's cheaper to fine tune. And then they use supervised fine tuning, and then they got their Alpaca 7 billion. So to really understand how they do this, I think we need to read the self-instruct paper. So self-instruction is the paper called aligning language model with self-generated instruction, without any humans to provide the instructions and responses to fine-tune the LM. So basically you start with 175 C task, right? And then you use the LM, for example, ChatGPT. But here, if you use a ChatGPT, then it means that you can only use it for research purpose because the OpenAI license does not allow you to use their data to develop a competing LM. So you may use it to for research purpose only. So you can use, for example, ChatGPT over here, right? And then you ask the ChatGPT to generate more task instructions. So basically you populate your task list by showing these examples to the LM and then ask the LM to give you more tasks, to generate more task instructions. And then you prompt the LM again, and then classify the task to see whether it is a classification related or not, right? So for example, here, this is a classification related. So then you need to predict the class label for the task, or it is just a general text generation, right? So this is the input example, and then you need to generate the output given the input. So basically they run use the LM to run a classification to decide whether the task is a classification task. And then they will prompt differently, right? So for the language model to generate the examples for the task instructions. If it's a classification task, they will output the class label first, and then they will generate like what is the input for the class label. So they call it like output first to predict the class labels. And then if it's like input first, they will first input the topic, right? And then the output is to provide the code given these task instructions. Then they use a powerful LLM to generate lots of examples for the instructions given. And then basically they connect lots of data sets, right? And then they filtering it. I think for the filtering, you can also use the LLM to evaluate the qualities of the output. And then you pass the high quality outputs to your task pool. And then you can do this loop over and over again so that you connect lots of like instruction, like task instruction, and also the results responses for the task given these instructions. Yeah, so you see like a LLM is used everywhere, and it's kind of like a it's a looping, self-growing process. Their paper is also very interesting. Like if you look at the paper, there's no fine tuning involved. It's all how you prompt the LLM, right? For example, for the first step is the instruction generation. This is their prompt, right? So you just for example, tell the ChatGPT like come up with a series of tasks, right? And then you give a few short examples in context, and then the LLM is going to give you another instruction for another task over here. And then this is a classification task, right? So they want to classify whether the task is a classification or not. For example, here, like given my personality and the job, tell me if I would be suitable. Yes, this is a classification. And like give me an example of a time when you had to use your sense of humor. And then this is more like a text generation task. So it's not a classification task. So it's a no. So basically in the prompt, they provide lots of these examples. And then they copy the instruction for the target task over here and then ask the LLM to predict whether it is a classification task or not. So that's a step 2. And step 3 is like given the instruction, we want to generate the examples, basically the instruction following responses for the task, right? So same here, like come up with examples for the following task, and try to generate multiple examples if possible, etc. And also they give like in context examples. Actually, they give lots of examples. I short break it into 2 or 3 examples here, like which exercise are best, right? Just give a list and convert this to Celsius and direct output. And also you ask the prompt LLM to sort the given list ascendingly. Like they can, like for example, you can provide like 2 examples here, and then you just directly insert the instruction for the new task, and then ask the LLM to generate like examples to this task instructions. So this is, I think this is like input first approach, that the output is more like a text generation, that you need to give the input first if the input is needed. For example, if you need to sort a list, you need to have your input first, and then you generate the output. There's also like a classification task, right? Remember that they also classify the task, whether it is a classification or not, right? So for the classification task, they will predict the class label first. For example, so here is the example, like a context learning examples they provide in the prompt to the LLM. Like for example, the task is to classify the sentiment, and then the class label is this. And then this is the sentence, right? So for the classification task, they want the LLM to generate the class label first, and then the input, the examples for the task. And also like a different, even like whether it's the class labels is satisfied or unsatisfied, and then the LLM can like gives the class labels. So basically you provide these examples and then same, right? So you prompt then you add your instruction for the target task and then ask that the LLM will generate the class label first and then the input example for that. Yeah, so basically this is what that paper is about. So they use the LLM to generate a list of tasks and also use the LLM to generate the responses to the task instructions. And what they find is quite interesting is like the LLM can self-teach or self-learn, self-improve themselves, right? So this is what it means. For example, if it's a GPT-3, GPT-3 is not instruction fine-tuned, right? But yet they can still prompt the GPT-3 to generate the task list and to generate the responses to the task. So in the beginning, the performance may be bad. And then after you give it like more iterations and ask the GPT-3 to generate like more instructions and more responses, the instruction following ability of GPT-3 actually improves over time. So it means that actually the LLM can teach itself just by like generating all this synthetic data set, this instruction following synthetic data set to teach itself. And of course, the instruction following synthetic data set is not high quality, right? So, but it's at some point it will saturate. But they also show that it also can improve from a more powerful LLM. For example, the Instruct GPT, which is a instruction fine-tuned version of GPT-3. So the output from Instruct GPT will be much higher quality than the GPT-3. So if you use the Instruct GPT as your teacher model to generate the synthetic data set to do the instruction fine-tuning, the performance will greatly like improves a lot, right? Like jumps a lot if you give more better instruction following examples. So that's the main conclusion of the self-instruction. So this is the result. It's also very interesting. Like the GPT-3 is not instruction fine-tuned, and then they basically say they just use the GPT-3 to self-instruct itself, and then the performance like kind of improve a lot. Like the LLM can learn by itself to just doing these iterations and generate more like a synthetic instruction following data set. They can improve their own ability to follow the instructions. And also you can see like they compare the GPT-3 self-instruct with the Instruct GPT, the first version of it. Like Instruct GPT has several versions. With the first iteration of Instruct GPT-3 GPT, the performance is already getting close to the Instruct GPT, which is fine-tuned on instruction following data sets collected by humans. And also they also find like even with a large amount of labeled instruction data set. So this is like a GPT-3 with the human labeled instruction data set. So this is the instruction following kind of the performance in the end. And if you instruct first, right? So you still use the synthetic data set from the GPT-3 itself with the human labeled instruction data sets, the performance actually improves. So it means that actually if you have the human labeled data set, but you use the LLM to still leverage the self-instruction capability of the LLM, the performance is going to improve. I think it's a very interesting discovery of to show how the LLM generate a synthetic data sets and use that synthetic data set to train the self and how that can improve the performance of the LLM. So that is Alpaca, like relies on this self-instruct paper and then fine-tune the LLaMa model, and that results in the Alpaca model. So the Alpaca results, so they just fine-tune a 7 billion LLaMa model, and the teacher model is actually from the OpenAI text DaVinci model, right? And then the cost is less than $100. Yeah, so they can start like doing more interesting research with this instruction following data sets. Yeah, they also do a blind pairwise comparison between the teacher model, like this OpenAI model, and the Alpaca 7 billion, and they find that the two models has actually very similar performance. Yeah, so it means that actually the student model is learning very well from the teacher model synthetic data sets. Yeah, this is what they released at that time. So basically they just released the dataset, like these synthetic datasets, this data generation process, and also the training codes, but they haven't released the model weights. Because I think that at that time is the like LLaMa 1 is for research purpose only, right? And I think they at that time they mentioned that they will reach out to LLaMa to figure out whether they can release the weights of the model. Vicuna, I think you may hear about it many times, because the Vicuna is kind of the, if you want to do research in the instruction fine-tuning space, Vicuna is a good starting point for you to run your experiments, run different baseline, and lots of other research benchmarks or variants are based on Vicuna. And again, Vicuna is also not a rigorously like published paper. It's just like a web page released on end of March last year. And also it's also very straightforward to fine tune a Vicuna. Like the Vicuna is just like fine tune the LLaMa model on a user shared conversation collected from shared GPT. So the shared GPT is kind of like a website where it connects all the human and LLM conversations. For example, like if you chat with the chat GPT, right? So basically you can post your conversation with the chat GPT and post it in the shared GPT websites. And then they just use this conversation data to fine tune the LLaMa model. And they use the GPT-4 as a judge. I think the novelty at that time is that they use the GPT-4 first time, kind of the first time explorer as like using the another LLM to as the judge to show how it can achieves high quality of outputs comparing to other LLM, and also how it's like outperforming other models like the LLaMa, which is understandable since they directly use LLaMa and further fine-tuned, right? And also including Alpaca. And also the cost of training Vicuna is low, it's just $300. Yeah, so Vicuna is just like take the LLaMa and then fine tune it on a shared GPT, basically the conversation between humans and any LLM at that time. And then they use the GPT-4 to evaluate the outputs to compare with other LLM. So this is a model comparisons of different models like LLaMa models, Alpaca, and Vicuna. Yeah, this is just what they claim they train the model. So basically like the model training, right? For example, for Alpaca to actually call the OpenAI API to generate the synthetic data, they spend a few more $100s to create that synthetic data sets. Yeah, but I think it's a limited budget for research, right? So if they want to do more fun with fine-tuning the LLaMa model and to see what fine-tuning strategy is the best, or what is the best criteria to evaluate different models, then I think it gives a very good starting point for the research community. Yeah, so the main difference from Alpaca is fully fine-tuned on the self-instruction synthetic dataset from DaVinci model, and Vicuna is fine-tuned on the user-shared conversations from the human and ChatGPT or Vicuna chatbot that they released. So this is their model performance. Yeah, so they report like a relative response quality accessed by GPT-4, which means that they treat ChatGPT kind of as 100%. Like they give like a 100% score to ChatGPT, and then they asked the GPT-4 to give a score for each of the response of this LLM and to see like how good that response is comparing to ChatGPT response, right? So basically they asked the GPT-4 to give a score. So, and then they find that, oh, the GPT-4 kind of gives like above, on average, 92% for all the Vicuna outputs. So they give a headline, say, oh, the Vicuna 13B is achieving 92% performance of the ChatGPT. But to me, it's not like a very rigorous approach. And this is actually from their comments, discussions as well. So they just say like the GPT-4 shows the potential to automate the chatbot assessment, but it's not a rigorous approach. And they also find out that GPT-4 is not a good, at that time, it's not a good judge for coding or math problem. So yeah, the performance may be best. And also how to build an evaluation system for chatbots is still open questions. Yes, I think it's a objective feedback from the team itself. But if you look deeper into the responses, like if you just count like how many times Vicuna won and so how many times is a tie, and how many times they lost, like this is comparing to LLaMa 13B, Alpaca, definitely is beating Alpaca. But for if you compare to ChatGPT, Vicuna only won 14% of the times, up to 18%. And it's given a tie 22% of the time. So clearly ChatGPT is still like winning most of the cases. If you look at their like release history, so they released the Vicuna here, like for LLaMa 1. And then they start kind of sponsoring and maintaining the chatbot arena for battles upon LLM. I think this is quite interesting too. And this way also for them to connect more human LLM conversation datasets so that they can use this to fine-tune the Vicuna to a better version. Yeah, so yeah, this is their evaluation tools, and this another data sets for evaluating chatbots. And then when LLaMa 2 is released, they also release the long chat data sets, the weights. Yeah, and then they also release the Vicuna version 1.5 based on the LLaMa 2. So basically, whenever LLaMa is released, they will also need to upgrade their versions based on the newer versions of LLaMa. And also they release this real-world LLM conversation dataset. This conversation dataset is mainly from the Vicuna demo that they open up the API for people to interact. So they connect the conversation dataset. They also connected from the Chatbot Arena website where everyone can post the LLM and human interaction conversations over there. Yeah, and then they connect this 1 million LLM human conversation dataset to kind of you can basically use this dataset for research and to figure out, okay, what is the best instruction fine-tuning strategies, and also they can upgrading the Vicuna model based on the newly connected conversation dataset. Okay, then let's go look at the last one. I think is also a very interesting idea on the how to bridge the gap between the text model and image model, right? So people have, I think there are like two large communities. Like one community is like releasing all these vision encoders. You can think of these vision encoders as the text encoder as well. Basically, you can transform an image into a vectors representations. Right, and then the text community side, like especially the large language model, right? So LLM language model. So basically, it's mainly targeting in the language processing. Like focus on the reasoning, the knowledge, and also the few shot abilities. So how can we bridge the gap between the vision and LLM? So LLaVA is trying to help the LLM understand the token from the images by adding projection layers, right? So you can take any vision encoder such as CLIP. You can search for CLIP. I think it's a very commonly used vision encoder. And basically it transforms the images into again over here is like tokens, right? So you can think of like images, like break it down into patches, and then for each patch you got a token, a vector of values for that patch, and then it uses a projection layer to transform the image token to another, like you can think of it as text tokens that the language, the LLM can understand, right? And the language part, you will be already have these language tokens that the LLM can directly take in. Well, it uses this projection layer to transform the image tokens into another set of tokens that the LLM can understand, and then it will combine both the image and text together to generate the final response. So this is the main framework of it. They just basically, the key part is this projection layer to bridge the gap of the image tokens and the text tokens. And also it's very interesting to see how they train this model. So there's also like a pre-training stage and a fine-tuning stage. So pre-training stage, language model and vision encoder, all the parameters of the models are frozen. They just train the projection weights kind of to align the image token and the text tokens, right? So you can, that's why it's called like a feature alignment. So they only update the projection layers while freezing the vision and language models. And for the fine-tuning part, the vision encoder will be still frozen, and then they will fine-tune both the projection and the language model weights for the final to improve the final response of the instruction following task. This is their fine-tuning data sets. So I think a key part is how do you generate lots of fine-tuning data sets to fine-tune your the LLaMa model, right? And since the LLM is out, I find lots of paper use synthetic data sets from ChatGPT or GPT-4 to fine-tune their model. And one interesting part is that for the data sets, they I think they still use a text GPT-4. So basically, they still use a text GPT-4, and the input to the GPT-4 is the captions of the images and the bounding boxes of the object in the images. So basically, this is their context. They provide it as prompt to the GPT-4, right? So for example, this is a caption, like description of the images, and this is like the bounding box of each of the object. And then they send this context information as prompt to the GPT-4 text-only model, because they want to make sure that it's purely like they want to just train the LLaMa, right? So based on the really test out the multimodality case. And then when they generate these examples, they only use a text-only LLM like the GPT-4, given the context information and the bounding boxes, and then ask the GPT to create a list of questions with the intent to describe the image content, and also to ask the GPT-4 to describe the kind of the responses to that. So this is some like a GPT-4 responses given the captions and bounding box. Like there's a conversation style, like the detailed description, and also complex reasoning, like what challenges do these people face, right? So and then the GPT-4 will generate kind of the answer based on the description and the bounding box. So they basically connect lots of examples like this through GPT-4. And this is the prompt they use to generate the conversation from GPT-4. Like you are the AI visual assistant, and right now, I tell you about all these descriptions and objects, locations, and consider all the relative positions of the objects, right? And then you need to like generate kind of the conversation between the assistant and the human to kind of understand the visual content of the image. And also it said like give detailed examples, reasoning steps, so kind of add more these instructions to the prompt. And also they also provide GPT-4 like a few short examples over there. So this is how they use GPT-4 to generate all these examples. And then, so this is the results of for example, the images here. And then the user asks like, what is unusual about this image? And this is a LLaMa response. And what is happening in this scene? Like the LLaMa gives like a very detailed response comparing to GPT-4. Like if you prompt it with GPT-4, the GPT-4 is like just a brief description of it. And I mean, it's hard to say like which one is better, but yeah, depending on like what you really need or what instruction you give to the LLM, right? You want to give you more details, or you want to give it like a concise output with a limited number of words in the response. So they compare it, and again they use the GPT-4 as the evaluator. Because the GPT-4 kind of know the ground truth, right? The ground truth of the image descriptions and the bounding boxes, while the LLaMa model do not know that. The LLaMa model is prompt only with the images directly and the instructions. And then they compare the performance on the LLaMa, the benchmark datasets, and with different training datasets. So like no instruction fine-tuning, the no instruction fine-tuning part means it's just using the clip plus the Vicuna model, and the weights is not like instruction fine-tuned at all on the images and text, so the performance will be bad. And then they fine-tune it on the conversation data, they fine-tune it on the details on the complex reasoning data set or the full data set, and then they see the performance kind of gradually increase by adding more enriched, complex training datasets. They also benchmark it against other multimodal model at that time, like the Open Flamingos and Bleep models, and they are able to show the improvements by using the GPT-4 as the ground truth over here. And GPT-4 basically like generate the ground truth based on the image details and the bounding box, and then they ask the GPT-4 to compare the GPT-4 ground truth response versus the response from each of these LLM, and then ask it to kind of evaluate like how good that result is, like how helpful that is, how truthful that is, etc., and then gives a score on that. And then this is the kind of the final performance comparisons across different LLMs and across different tasks. Another one I find is also interesting is on the science QA. So this is another benchmark datasets for science-related questions, like natural science, social science, language science. So some of these subjects can include both images and text in the problem statement, and then you need to come up with the answers to that, right? That like the test cases. So human on average can get like 88 scores of these problems. And then this is like ChatGPT 3.5 is text only, means that you do not use the images in those problem set, then purely text-based, what is the performance? So it's around 73, 75. And then you start like using this multimodal model. So MM stands for multimodal. another multimodal model, and actually this model gets actually a very good performance, like up to 91% on the science QA dataset. But I did look at this paper. This paper, the only benchmark they compare is this one dataset. So I'm wondering whether this model is just designed and fully fine-tuned only on this one. So that's why the performance is like a great improvement over the others. Yeah, I mean, if this paper can show their performance across other multimodal class, the results can be more convincing. And then they also show the GPT-4 performance. This is text only, and the LLaVA their model, and then they combine the LLaVA and the GPT-4 together as a complement. So whenever GPT-4 cannot give a response, they use LLaVA's response, or they also use a GPT-4 as a judge. Like a GPT-4 to say which response is better, like the response itself or from the LLaVA response. So then then the final response is from whichever is better. And then they are able to show the ensemble model is able to perform the best over there. They also mentioned that their novel model ensembling with the text-only GPT-4 improves the model performance under all categories. It seems that there's a trend in the community, like using the powerful LLM such as GPT-4 to, for example, create a synthetic data set or use it to judge the performance, and even like use it as one way to ensemble your model so that you can see improved performance on the benchmark. Yeah, I think it's a pretty cool idea over here. Yeah, I think that's the LLaVA model. And that's the end of what I want to share. And I hope that you get you some idea of how people are using LLaMa models, right? How they are kind of adapt LLaMa models for their own use cases, and how they can enhance the LLaMa capabilities for the instruction following, or increase or enhance the multimodality performance there. And yeah, and that's the end of the meetup. But I'm open to any questions you have or any other suggestion. And for the next one, I think we will focus on like a hands-on session. Let's see whether we can fine tune or a LLaMa model, like have some hands-on sessions or smaller LLM based on the computing resources. And all the post recordings have been published to this YouTube channel. So, and all the like past series about LLaMa models have been already published here. And also today's meetup will also be posted after the meetup.